The question number 16 says that graph of the displacement time for a particle executing simple harmonic is shown, the corresponding acceleration versus time graph. Now dear student, if we look carefully, then this is minus a sine omega t graph. Because start from here and see, when you take the acceleration, that is equal to minus omega square x, so that become omega square a sine of omega t. This is the maximum value, which is a constant amplitude maximum acceleration. So this would be a sine graph, and the sine graph out of these is the fourth one. With this value, maximum value is omega square a. So the correct option to this is option number 4. The question number 17, two particles with the same masses are performing simple harmonic motion along x-axis, so the displacement versus time graph are shown. The ratio of their maximum kinetic energy. See, the formula for kinetic energy is equal to 1 by 2 the mass omega amplitude, and for the kinetic energy of 2 mass, which is given same, omega 2 square a2 square. Now to ratio of k1 by k2, so when you divide this become omega 1 by omega 2 whole square and a1 by a2 whole square, and this value we'll find from the graph. Now see, this is the graph number 1, this one, and this is one cycle, it finishes here. But for this other, in the same time, these are two graphs, I mean two complete loops are completed. Therefore, so omega 2 is equal to twice of omega 1 because frequency is double. And also let's see the amplitude. This is graph 1 whose amplitude is a, and this is a graph 2 whose amplitude is 2a. Therefore, a2 is equal to twice of a1. This is 2a and that is this one. So when you fill here, so omega 1 by omega 2 is equal to 1 by 2 square into a1 by a2 is again 1 by 2 square. So this value become 1 upon 16. So k1 by k2 ratio is 1:16, and the option 4 is this one. So the correct answer is answer 4. Now the question number 18 is, a small particle of mass m is attached to one end of a light string of length L and other end is connected to the ceiling of a satellite revolving around the earth in circular orbit. The satellite is at a height h is equal to 2r above the earth's surface. Then the time period of oscillation of this mass. But dear students, you know that this is a satellite which is revolving around the earth in this orbit, and this satellite is basically falling because it has the acceleration toward the center, and every material in this one is weightless. So if the pendulum inside is weightless, the g is equal to 0, and if you disturb, it won't come to the mean position because there is no restoring force. Therefore, if g becomes 0, t become infinite mathematically, or it won't vibrate at all. So therefore the correct option is answer 4. Let's move to the next question. The question number 19 says that a uniform rod of length L is suspended from one end and is made to undergo small oscillation. What is the length of the simple pendulum which has the same time period as that of this rod? Now dear student, if this is a rod of length L, it is suspended from this point, then time period is equal to 2 pi I upon mgd. D is the distance of center of mass from the point of suspension, which is L by 2, and moment of inertia about this point, that is equal to ml square by 3. So its time period become t is equal to 2 pi 2l by 3g. And if you take the simple pendulum, then the time period of simple pendulum is 2 pi root of l by g. If both have the same time period, so what you conclude that L prime should be equal to 2l by 3. Therefore, the correct option is option number 4. The question number 20 is a particle is executing its HM with the amplitude of 5 cm about x-axis, having its mean position at x is 0. The speed of the particle at x equal to minus 2 cm and x equal to 3 cm are v1 and v2. Then the value of v1 and v2. Now see, the speed at any instant v is equal to omega root of a square minus x square. Right? Therefore, I fill up the values. That is equal to omega. Amplitude is given to you 5 cm and x is given minus 2 square. So that is equal to omega 5 square minus 4. So that is root of 21 omega. And what is the speed at the second point? Where x is equal to 3, this is omega a square, that is 5 square minus x square means 3 square. And that is equal to 4 omega. Therefore, v1 by v2, the magnitude ratio is root 21 omega divided by 4 omega, which is equal to root 21 divided by 4. And the first option is root 21 by 4. So the correct option is 1.